is such an amazing audience, such an amazing country, and such an amazing future.
Latitude59 welcomes you back from the break. We're going to have here on the stage somebody who's quite extraordinary. The company's Planet OS, and what the company is trying to do is to understand our home planet and to understand how the planet and the environment affects us. They were also one of the supporters of Garage 48 Space Tech, which is a part of the same ICT Week event series and was just finished day before yesterday. And from the Planet OS, we have somebody who runs their company in Silicon Valley. He's a guy who's also known in Estonia as somebody who has made the electric charging for the electric cars available here and created our Statue of Liberty. Rainer.
All right. Thanks, Brit. Hello, Tallinn. It's good to be back home. Today, I want to talk about something I'm very passionate about. But before I do that, I wanted to ask you, can you raise hands who's in Tallinn for the first time? It's about 20%-ish. Welcome. And today, when I walked in here, I felt as if I'm a tourist myself. I've never been in this facility before. And today, I want to talk about something I'm very passionate about, which is the future of the digital Earth. And digital Earth is a term coined by former Vice President of the United States, Al Gore, in '98. And it's really about how do we affect the planet, us as being humans, and how does the elements affect ourselves. Before I do that, this is a photo I took in the San Francisco airport just before coming here. And the end of code here means that we'll eventually teach machines how to write program code for ourselves, therefore automating automation. And while I'm very excited about this machine learning and the sub-disciplines going mainstream, I'm thinking this is not really that case right now for the geospatial world. When we talk to software developers, when we talk to energy companies, when we talk to government agencies, we get the same thing all the time. It's really, really hard to integrate data to build killer apps. And data integration is a kind of a decidedly unsexy area, yet it often becomes the obstacle to create very meaningful things. Now, by now, you're like, wait a minute, Rainer, what are you even talking about here? Like, why does any of this matter, and what is digital Earth in the first place? So let me give you some context. In the past 5 to 10 years, humanity has wired up the natural world, deploying sensors everywhere so to understand what's happening. In fact, geospatial data is outgrowing all other data types except video. Let me give you some examples. So let's take an offshore wind farm or a coastal wind farm. It may have many owners, but normally one party is responsible for its profitability, the operator. Now, okay, you have your asset performance management in place, but what about the elements? What about the external effects on your operations? So by knowing your limits, what's possible, and by bringing data together from the government, from your own devices, and integrating that in an integral way allows you to actually sustain your business and deliver sustainable energy. Some of you who raised your hands who are in Tallinn for the first time may have flown in here across the ocean, so you flew a 747. So here's a jet engine from General Electric, and this is a company that's transforming itself from a product business to a service business. You can see that all over the place. So it's not selling jet engines anymore as a product, but as a service, which means if you take two identical jet engines, one flying from Abu Dhabi to Paris, and the other one flying from Abu Dhabi to Shanghai, their lifetimes will be different, because in one case, you fly from sand to clean air, and in another case, you fly from sand to dusty air. And so you want to make sure the lifespan is going to be long enough. You want to make sure that the passengers are safe. You want to make sure that you're going to make money on your jet engine. This is a big thing. At the same time, weather is becoming increasingly unpredictable. where I currently live in California, we have had a 5-year drought. This is a photo just before the last rain season started, which eventually did still come, luckily. And so all these things are happening, and this is the only graph in this presentation, I promise. So you have convergence of two massive markets. One is the industrial Internet of Things, and the other one is geospatial services. So these are very much overlapping these days. And so the natural question is, what do you make of all this? What do you do with this ocean of data? In PlanOS's case, what we want to do, we want to make Earth data flow like electricity. What does that mean? That means that for large energy companies, we help to integrate a lot of different variety of data into a cloud environment that makes them to run their wind farms better, their solar farms better, their power plants better, their electric grids better, things like that. But our larger mission is much bigger than that, so to speak, the big, hairy, audacious goal, as we say in Silicon Valley, which is really to make all geospatial planetary data universally discoverable, accessible, and usable by everyone, not just data scientists or researchers, but really everyone. And by making it available, like electricity, it enables their creativity and enables them to make decisions better for the planet and for ourselves. So really what we're doing is building an API for the planet, which you can check out at data.planos.com, and we like to call it the programmatic planet. And let me give you a couple of examples. Let's say that you're building a surfing app for windsurfers. You might be interested in getting a specific data point on wind speed in a specific location or an area. Okay, then at the same time you want to know the wave heights and swells. So it might be that you are using two different sources for that, two different even government organizational sources, and it's really hard to find this and use this information. With PlanOS API, you don't have to do that. With PlanOS API, you can just have one singular API, and you're off to the races. Or if you're building an app for the agricultural space, analyzing yield, or what have you, then you may be interested in precipitation. Obviously, rain will be important for you. You may be interested in soil moisture. Again, this data is very hard to find, very difficult to use, and with the PlanOS API, you can just use that. Or a final example, if you're a commodity trader trying to place a sale on your solar production position, then you might want to monitor the maximum temperature in a particular area where your solar farm is at, or look at the total cloud cover, because that obviously will influence the output of your farm. So things like that are happening on a daily basis, and they happen in the background. And some of you may wonder, like, what is this guy even talking about? There's so much work in the background that this really hinders people to build better applications and for us to understand our planet in a better way. So in fact, in the last couple of months, what PlanOS has done is put out over 800 parameters, all available under one single API. And this is just the beginning. We're putting out more and more data sets every week. And everybody loves a good community. We have a Slack community, which is pretty active. People are using this information. We're updating this information all the time. So it's great to see people who are contributing to the community as well as building interesting things. And, since this information is kind of heavy to use and hard to use, we want to make it even simpler. So we're continuously publishing information on and notebooks on how to use this information. So it's not only, again, specialist, but our goal is to have 10-year-old kids in the future be able to build this. And when we were giving a talk on this very same subject at the United Nations about half years ago, our goal was really to make planetary data available for school kids as well. But this is the longer vision. So we think this is better for everyone if we bring the best data sources to the masses and build tools to use this information. The users will be happier. We'll know what they do with the data. We'll know what other data needs to be brought in. We will know what kind of infrastructure we'll need to build, and so forth. It creates this virtuous cycle and helps everyone along the way. So to wrap things up, and I wanted to make it shorter than I was given, we're very excited about the future of the digital Earth. We think that we're building a programmatic planet. We think that we're going to be able to control what we are doing with the planet and how the elements are influencing us. And if you have any questions, I'm around. Thanks so much.
Thank you, Rainer. whoever wants to ask questions, get ready. But I'll ask the first one. So you're attacking very big problems, and the solutions actually to these problems are pretty large as well. What could be the short-term or very impactful things that having this better planet data actually be? Like some practical things that somebody accessing your data could solve in a year, 2 years, 3 years time actually?
Well, a lot of the data that's been made available is made available by governments. So even the governments that are putting out data are not even making it accessible for their own sake. So they cannot use their own data. So that's from one end. So this is the heavier end, and we work with the enterprises. On the other hand, big data is also small data. We might want to work with the community that can publish their own information and then can give away. This API is free for everyone to use to a certain extent, so people can actually build things and share with other people, and then they can find adjacent data sources. So it's like a nice kind of a viral effect that happens within the community because people share and they like to share information. So it's a programmer's solution to understanding the planet.
Okay. Any audience questions? Hands up. What's actually for you the biggest challenge in doing this? Is it collecting the data, visualizing the data? Is it like getting people to use the data or access your system? So what are, also as an entrepreneur, you have challenges day in and day out. What are the biggest ones for you actually in doing this big thing?
So yeah, two things, technical and business. The technical challenge is we want to make Planet OS an invisible company. We're doing our job well if you don't even know you're using Planet OS. If you're using some data sources to understand weather patterns or climate, and we're working with NASA, and they don't even know that we're there somewhere, sort of like you flip a switch and the electricity comes on, you don't even know, what's the utility, then we're doing a good job. That's probably the hardest task that we're really doing, and that creates our competitive advantage also in terms of technology. In terms of business, the challenge is how do you make something that big scale faster? And so you have large organizations that we're dealing with in terms of sales, and then you have users, regular users that may want to build a surfing app. And so we have figured that out in the sense of putting an API out there for people to use for free, while at the same time servicing larger organizations ourselves and together with our partners.
Okay, thank you. Now, any questions still from the audience? It's always hard to get the Estonians warmed up. You don't actually have to ask about Planet OS as a product. So Rainer has a big experience in actually, moving to Silicon Valley and building the company there. So one question there. Can we take microphone there? Introduce yourself as well.
Hi, Bill Reichert with Garage Technology Ventures. Rainer, so tell us, why did you move to Silicon Valley?
Yeah, that's a good question. So Planet OS has offices both in Silicon Valley and in Tallinn. We have 5 people remotely elsewhere as well. We have Montreal, Rio, New York, Wrocław. I'm missing something. Los Angeles. The reason why I moved to Silicon Valley in the beginning was the United States spends about 80% of all the investments into geospatial sensor data comes from the United States. So really our customer base is there. At least in the beginning it was there. Today we're doing a lot of business in Europe as well. So our idea was to build a very strong core tech competence here in Tallinn and then build a customer front out in Silicon Valley. And the space we are in, this whole geospatial, is very technical, and a lot of the thought leadership and database technologies, which we're not a database company, but we use a lot of those, is really in that area. So for that reason, I really moved.
Thanks.
We have one question here.
Thank you so much. My name is Ari with Dream Ventures. I'm wondering, with this platform, what your views are on the future of renewable energy production.
Yeah, thanks, Ari. Well, everybody wants to go greener, and Planet OS is a perfect partner for renewable energy because renewable energy is very volatile. It's very hard to predict what the wind's going to be and then what it's going to do, and then you have solar and things like that. So with that kind of volatility, your investments are normally at risk. You just kind of want to control this environment better. And then what we have done working with our partners in the energy industry is to create a solution, study that process, and then create a value analysis to show them how much money they can actually earn more thanks to Planet OS. So we're seeing a huge curve, and you all have probably read the news in the recent weeks. There have been countries run 100% on renewable energy for several days in a row. So we're seeing that kind of trend, but it's still very hard to maintain that level of renewable energy. At the same time, it makes a huge load for the grid. I don't want to go too technical here, but really, we believe that data-driven approach to a physical world problem is really key here, because the hardware-driven world is already optimized. It's already to its maximum extent.
One question there.
Morning, Rainer.
Hey.
I've been following your company from beginning. It used to be called Marine Explorer.
Yeah.
It was a nice dream of sailing on the sea. Now it's a Planet OS. My question is, why your brand is still limiting you? Why it's not Universe OS? Why don't you want to collect data about the Mars and Moon and other stuff? Why you are with the 2 feet on the ground if you're already flying?
I'm a big fan of Elon Musk. And yes, we should go to Mars. But we kind of have to stay here for a while. So I think, just to turn it around a little bit, what we saw with Marine Explorer is that a lot of these processes that we were working with in the ocean space are really can be translated into on land, sort of an evolution. And people start to come to us as well, like from a technical standpoint. People that work in the marine space with data are far more advanced than people on land because they have to deal with this small thing called the ocean. So for us, it was a very natural way to expand our markets and narrow our focus. And ever since we changed our name from Marine Explorer to Planet OS 2 years ago, we've been thriving.
Any other questions? We are soon getting to the topic of founder stories as well. So anything related to that maybe? One there.
Rainer. Can you name some of the applications which maybe we as consumers might be able to see from app stores or somewhere? Has somebody created something like that already based on your API?
I'm sorry, I'm not getting...
Did I understand the question correctly, that are there any example apps that are built on top of Planet OS already, either
Exactly,
mobile or web-based? So can you give some examples of what has been built on top of it?
So we started publishing data sets under our API 2 months ago. So far, we've seen 2 surfing apps that start to use this. There's an agricultural app that is starting to use APIs. We are seeing insurance, which is quite interesting. So insurance is definitely a potential future market. So these are, I would say, the most popular examples. And surfing is interesting because it's a very specific problem for people that are surfing. And so you don't want to look at your surfing forecast and show up and there's no surf. So you want to bring in additional data points to be able to do that. And the whole point about that is that it used to be that you forecasted weather based on models, like on some 10, 20-year statistical models. Today, companies all around the globe are using real data, empirical data, to actually make decisions about the next 12 hours. So I think that's really what's driving the developers and asking us. But yeah, in terms of the API usage, we're seeing a lot of sort of lighter weight apps in the beginning, which is perfect for us while we are working with bigger companies ourselves. And the more robust the system gets, the better for everyone.
Yeah. How long and how big part of the data will you actually keep for free? And big part of your business is selling the data and selling maybe the API access. So where do you actually draw the line? Selling API data is always a tough issue. How to do it well?
So our business model is actually pretty simple. For the API, it's free to a certain extent, and then beyond that, you have to pay. So the public data is always free because it's paid by taxpayers. If you decide to buy some commercial data sets, then we take a revenue share out of that. So that's a very simple business model. So you can check out the pricing, which is very competitive on our website. On the other hand, when we work with larger organizations, then what we like to do, and which is a bigger trend in enterprise software, which is that I don't want to just come in and sell my product. I really want to deliver value, which means that I'm going to bring a solution and I'll prove it to you, and I'm going to tell you exactly how much money you can actually earn more because of that, and then I'm going to say to you, I want to have a percentage of that benefit.
Okay. So to wrap up, as a last question, I'll ask one myself as well. Now living so long time in Silicon Valley, you have this external person's view on Estonian startups, Estonian entrepreneurship, and so on as well. What's your kind of number one suggestion to Estonian startups, either those starting up or those operating with 10, 20, 50 people from a distance? What would you tell the fellow entrepreneurs?
Very simple. Talk to your customers.
Okay, thank you.
Thanks. All right.
Aitäh.
Thanks.
Thank you.